Checking each word against 3 keyboard rows looks like it needs 3 nested scans, but a single character to row map lets us decide in one pass. The problem gives you an array of words. You must return only those words that can be typed using letters from exactly one row of a standard QWERTY keyboard. For example, with the input hello, Alaska, dad, peace, the words Alaska and dad qualify because every letter in each word lives on the same row, while hello and peace mix rows. A straightforward approach loops over every word, lowercase it, and then checks each character against 3 hard-coded row strings. For each character you ask whether it appears in row 1, row 2, and row 3, updating 3 Boolean flags. After scanning the whole word you keep it if any flag stayed true. This runs in O, n times L, time where n is the number of words and L the average length, but the constant factor is high because each character triggers 3 string searches. The key insight is to pre-compute a lookup table that maps every lowercase letter to its row number. First we fill a dictionary, all letters in QWERTY wipe get value 1, ASCII get 2, and ZXEVB and M get 3. Then for each word we lowercase it, read the row of its first character, and scan the remaining characters. If any character's row differs from the first, we discard the word immediately. Otherwise we add it to the result list. This eliminates repeated string searches and guarantees a single pass per word. You'll recognize this pattern when a problem asks you to filter items that belong to a single predefined group like same row, same category, or all characters from one set. Time complexity is O, n times L, because we examine each character once. Space complexity is big O of 1, constant time since the lookup table holds only 26 entries regardless of input size. Try the next problem, same pattern. Subscribe for more concise LeetCode walkthroughs.